So I'm Venkat. I'm the CTO of Turtle, and we help freelance software developers. We connect them to interesting projects, and we give them everything they need, the software development tools and the management support to be successful as freelancers. So why am I here today? Well, we at Turtle, we have a set of software applications of our own, and we have a team of Turtle developers that contribute to these software applications. And these code bases can get pretty large, and the team is also very diverse, especially in terms of they're spread across multiple time zones. Some are part-time, some are full-time. Some have been with us for over like a year and a half, while others will come for a 3-month project, and then they'll leave and they'll move on to other things. And we like to offer this kind of flexibility with schedules. But the challenge we had, or one of the challenges we had, was how can you architect your software system so that it's easy and efficient for a team like this to contribute to? And we experimented with a few options. We did some research, we ran some experiments, and it turns out we came up with a solution, and it turns out that this solution is applicable to all sorts of teams beyond just distributed teams, because if you take a look at remote teams, they have a lot more challenges to deal with in terms of coordination and communication. For example, if you don't have documentation and everyone's in the same office, you can just turn around and ask someone for help and you're on your way. But if someone's in another time zone and you don't have proper documentation, you might have to wait 8 hours to get an answer. So remote distributed teams, if they fall short on some things, their consequences are much greater. So they are forced to come up with best practices and systems to a much greater extent. So if you're in an office and you can turn around and talk to your colleagues, I would encourage you to listen up also, because this applies to you as well. The architectures here, I mean, despite the title name, are not just for distributed teams. They are applicable universally to all sorts of projects and teams. So just some screenshots of some of the different applications that we work on, all the way from budgeting to time tracking, chat. Who here has built a software application from scratch before? I'm sure everyone's hands are up. Or who here has been in the early stages of a project when an app is just getting started out? Okay. It's great, right? Because you get to pick everything. You get to choose your own tech stack, your programming language, choose your database, figure out your architectural patterns. You understand all the code, because there's not that much code. Maybe you're working with like 1 or 2 other people, and like things are moving quickly, right? Because it's just a few of you, and you're shipping features, major features every week. Small changes are happening like that. But this doesn't last forever, right? Like at this stage, this is probably the best it's going to get, right? I call this like the golden phase of a software project, and I've heard some of my friends call it the honeymoon phase, right? Because what happens, like what you have here turns into something more like this. A year later, right? A year later, your app is successful, hopefully. You have a larger team. Customers are demanding features. So you have to grow your team, and your code gets out of hand, and progress slows down, even though you added more people to your team. And it can be frustrating, right? Because you're putting out a feature, and it's taking you 3 weeks, and you're like, wait, this same exact feature would have taken me 1 week to do at the beginning of the project with no changes, right? Or you're adding a new engineer to your team, and they take a lot longer than you think they should be taking to contribute a feature. And you're hiring, and let's assume you're hiring smart people, so it's not because they're an idiot or something, right? So why does this happen? Well, there's many factors, but there's 1 or 2 that like kind of dominate the other ones, right? And there's a book that's it's like 40 years old. It's considered a classic by many, and it talks about why this happens. This is The Mythical Man Month by Fred Brooks, and Fred Brooks, I think he's like 90 now. He's like pretty old now, but so he was like working for IBM way back in the day, managing really large projects like operating systems, like many team members, and he saw a lot of things in software development. And he wrote his observations in this book. It's like a series of essays. One of the things that really stood out to him, one of the most famous observations from him, is called Brooks' Law. And what Fred noticed was when software projects were running late, of course, the natural thing to do if you have the budget is let's hire more engineers. So they would add more engineers to these projects, and he would see them actually slow down. And I don't mean like the progress was like it wasn't like you're getting diminishing returns. I mean like you have 10 engineers, and let's say it will take them 6 months to ship this product. You add 5 more engineers, and now suddenly this same exact product will take like 9 months, right? So it was actually counterproductive. It was being like things were being held back. And he noticed that there were two reasons for this when he dug into it. The first one was communication, coordination. So as the number of people grew in a team, there was more channels of communication. And everybody needed to coordinate with more people to get their job done. So like, imagine if you're on a team of 3, right? There's just 2 other people you have to talk to at most. Team of 1, like you don't have to talk to anyone. You can just like code, right? You don't have to worry about anything. But then when you have a team of 12, there's like all these different people you have to coordinate with. And so like you're actually spending your time doing meta work. You're like talking about work, but you're not actually doing work. So people were spending all this time doing this work. Sorry, people were spending time talking about work and not doing it. Okay. The other one was onboarding. So when these new people would enter the team, the senior engineers who knew the stack from day one and understood the entire system, they would have to stop what they were doing to onboard the new developers and get them comfortable with the system, right? And if it's a small app, that's fine. It doesn't take, maybe it'll take you 2 days. But in these large systems, they were stopping work for long periods of time. And so these 2 things like really contributed to these projects slowing down, right? And later I'll get into how, knowing this, we can design and architect software systems so that they're kind of immune to these kinds of effects, or at least a lot more immune than they are today. So with onboarding, we had this problem too. This is our React app, I think like a year and a half ago. I don't remember exactly. And it's a pretty standard folder structure, right? If you're familiar with React. And many apps, even like backends follow this. Like, backend you have like models, views, controllers. It's easy to do this because when you use a generator, or when you look online in any tutorial, it's always the folders by type, right? If it's a style sheet, put it in this folder. If it's a container, put it in this folder. So it's the natural thing to do, and that's what we did. Well, but this doesn't scale, right? And many of us might have seen this. As your code base grows and grows, like each of these folders grows and grows. Like I actually cropped this. I cropped this right here, but like I would probably have to walk out there to like kind of show you the scale, like how many files were here. So like imagine you're working on a feature, like you're trying to work on search, and you're a new engineer. Right? Where do you go? Like you have to like hunt around this entire code base. You have to find the style sheets relevant to it. I mean, maybe it's named correctly. You can start looking for stuff called search. But then you still have to understand how that fits into the rest of the system. So it's no wonder that at this point of our application, if somebody had some spare time and they wanted to help out for a few months, maybe let's say 2 months, they wouldn't be able to because it would just take too long to onboard them. It would slow our team down. So we just had to turn away opportunities to work with good engineers because our code base wasn't easy for people to jump in and contribute to. And we all kind of know this intuitively. Right? When you're in a small project with a small team, there's many advantages to speed. You can iterate much faster. Right? Small teams, you don't have to coordinate with as many people. Small code bases are easy to understand. Because they're easier to understand and there's less code, they're easier to contribute to. And it takes less time to onboard people. Right? Because imagine like you're coming to a couple thousand line project application. Maybe you'll be able to understand that thing in a few days, maybe a week, on your own even. They're not going to have, maybe they'll spend an hour with you explaining things to you. But what if it's 50,000 lines? That'll just take you much longer. So it's just impractical in certain situations to onboard developers with something like that. And I would encourage you all to think about onboarding as more than just onboarding new engineers, right? Who here has written some code and you come back to it like 6 months later, maybe a year later, and you're asking yourself, like, what monster wrote this code? Like, you don't understand anything. What does that mean? You have a question? Oh, sorry. Oh, you're raising your hand. You've done this. Yeah, we've all done it, right? And then you do git blame, and then you look at the username, and it's your name, and then you just don't remember writing it, and then you're scratching your head trying to figure out what it does, right? What's going on there? You're basically all new to the team. You're like learning about what this foreign code does, right? So optimizing for onboarding, or if onboarding is good, it's not just for new people, it's for you, it's for everybody else on your team, because when you're in a large code base and you have all these different parts in your code, you're not going to be able to remember all of it. That's just, unless you have like superhuman memory, you're going to come back to it and you're going to have to get familiar with it again. So just to summarize, like think about onboarding as like broader, right? You're onboarding yourself too. And in many cases that happens more often. So let's see how we can apply these principles with a concrete example, and I can kind of lead you to the solution that we arrived at. Imagine you have to build this, right? It looks pretty standard, right? It's a meetings application. You have your video feed, you got the avatars at the top of people you're talking to, and action items of what you want to get done. And you can use chat if you want to send links and stuff like that. So to a customer or the end user, there's really not like, it's just a single application, right? It's a single feature. For them, it's meetings. They go to the meetings page, they have a meeting. But to us, the software developers, we can think about it like 3 separate applications. You have your meetings, your meeting video feed application. You have your action items, your task list, and you have your chat, right? And if we took a big app, if we take this big app and we broke it into 3 smaller apps, we're now back at the advantages of small applications, which are easier to understand, easier to onboard people with. Each could have its own team, right? Working on each part. And when I mean separate application, I mean it has its own code base. It talks to the backend on its own. It manages its own state, right? But of course, we're not gonna build 3 separate apps and deploy 3 separate apps and ask them to install 3 apps and then open them up and like put them next to each other, like on their screen, right? That wouldn't be practical. But so we do still want to, like if we break these things into smaller applications, we want to be able to put them back together efficiently, which means to the customer, it's still that same application, and to us, we're working on 3 smaller applications, and we get the advantages along with those. If you've used React or any component-based framework, we use some React, we use Flutter, you can use Vue. It doesn't really matter as long as it's component-based. You already have one of the major tools to do this, right? Because if you think about it, an app is basically a component, right? You could build an entire video game and like put it inside of a component, and it would run, right? You could have if you embed YouTube on your website, you're basically taking the YouTube app and you're putting it on your website, right? So an app is a component. So you can treat each app would be in a component, and it would be composed just like you would with any other one, right? And just to clarify here, like if you're looking at this thinking, well, isn't this just a React app? Yes, it is, but this isn't enough. You can't just create these components and be done. Each of these would have to have its own folder. It would have to interact with the API directly. It would have to have like pretty much everything you need within self-contained. It needs to be independent, right? So if somebody's working on chat, they don't have to understand this giant system. They go to the chat folder, and they have all the functionality they need in there. All the files are there. So they're not having to wrap their head around this big system. They work within a small system, right? And Martin Fowler, who's known for a lot of his design patterns, we're not the only ones thinking about this. He calls these micro front ends. Unfortunately, that sounds like a buzzword, but he's already named it, so I guess we can't really come up with a name. But he says that once he focuses more on the scalability of the architecture. So like once you have a giant code base that's hard to maintain, take a serious look at micro front ends. So we're mostly there with the solution. So don't build large applications. Build small ones and put them together and have them operate like small applications, but to the user they're one. There's still another problem, though, that needs to be addressed. Otherwise, this way of working becomes unmanageable. So who here has had a simple fix to make, and you go to this part of your code, and then you change it, and then you break something like all the way over here, right? It's happened to all of us, right? What's going on there? What's happening is that you have a dependency between this part of the code and that part of code, and you didn't know there's a dependency there. It was like invisible to you. Or you could say it was an implicit dependency, right? And we have these all the time, right? If you have a variable name here and you change that variable name, and over here you're referencing it and you forget to change it, you broke a dependency. That dependency was there whether you knew it or not, right? You upgrade your package file, right? You break something, right? Dependency. You have a method, the function signature changes, right? What was dependent on that, right? So all these things that we deal with all the time are dependencies, and if your app grows in size, there will be more dependencies, right? Dependencies, you can't eliminate dependencies, you can minimize them, so you always will have to manage them. And if you don't manage them, you can break your builds easily. Or on the other side, you just have to be very, very careful to make sure, like, when you make this change, like, where else in the code am I affecting, right? I'm not going to cover back-end to back-end dependencies because this is a front-end conference, and that would make this talk kind of long. So if you're curious about that, talk to me later. But let's focus on these two major ones, front-end, front-end. The meetings experience you saw before depended on chat. And maybe other parts of the app use chat as well, right? You might have a task manager, and on the right you have a chat. And you might have a mobile app with chat, okay? And let's say the meetings team asks you to improve some feature with chat. And you make that change, right? Maybe all is good for the meetings team, but what about the other teams that are using your app? Like, how do you know like you're not breaking what they're doing? Like, what is the impact that you have on there, right? And it can become impractical to have to check this every single time you make a change. Front end to back end. Let's say, for argument's sake, you have an API on the back end that returns a list of users, and a user's got an ID, name, profile picture, right? And then for one reason or another, like maybe, business decision, you need to remove the profile picture, right? So on the back end, you deprecate it or you remove it. What parts of the front end are you affecting, right? Who should you send a message on Slack or Telegram, whatever you use, to tell them, hey, we're going to be removing it, we're going to be phasing it out, so you should probably update your code, right? So these dependencies need to be managed. Luckily, we're out of the dark ages of software development for the web, where we used to have to we were forced to write JavaScript and use REST APIs, right? There's still a place for those, but it's just nice that we have more options today. Like we have a lot of languages on the front end that compile to JavaScript. We have WebAssembly things. There's more diversity on the front end and back end, right? And this is 10 years ago, this would not have been the case. But now there's new tools available to us to help us manage things like these dependencies. I'll just pick one example, right? So static typing is very explicit, right? And I'm here to tell you that it's worth considering static typing if you feel that your application is going to get large. If it's ever only going to be small, you might be better off just using whatever's available. So TypeScript is just an example. Like we use Dart and Flutter on our mobile app, but you could use TypeScript, Elm, any of the more hipster languages. That's fine. But this will be the clearest comparison. I'm not going to get into the computer science definition of it, but the difference, these two code, both of these are equivalent, right? But on the top, I had to specify what a user is. I said it has an ID and a name, and this array it's an array of users, right? So if I try to access first name, which doesn't exist on user, it's going to complain to me, right? Or if I'm accessing name, let's say, and it gets renamed to full name, it's going to complain to me saying, hey, what are you doing, man? Like there is no such thing as a first name on a user or a full name. On the other hand, JavaScript's like super flexible. It's really just lets you do whatever you want. Like I could add like an array, like to this array of users, I could add like a fruit and a car and like a payment like record. I could add all these things and it wouldn't complain to me, right? I can access user 0.firstname, like birth date. Like I can access all these things and it won't complain to me until I run it, right? Until I actually go run it. And then when you run it, it's just like this longer feedback loop. And this is if you know about it, right? This is like you can actually see all the code here. But if you're in a large code base and you have all these dependencies going around, like these are invisible to you when you're using a dynamic language. So like if anyone who's worked in JavaScript may have dealt with this already, right? This is usually what's happening is you made a change somewhere and you didn't change the other part and you accidentally broke it, right? So if you're working on a small project, fine, stick with JavaScript, but at least consider the benefits of static typing along with the benefits and the disadvantages. There are disadvantages. You have to do more work. Like you saw the code at the top before was like what's bigger, it was longer than the one at the bottom. But think long term, right? If you're within a team, like what is the likelihood of someone breaking something if it's not even the code that they wrote, right? So on the back end, GraphQL, many of you may already be using this. I'm not going to get too much into what exactly it is if you haven't. I'll focus instead on how GraphQL is more like TypeScript and REST is more like JavaScript. GraphQL means it's a statically typed, essentially it's a statically typed API, meaning the backend developer, when they're writing the backend, they are specifying the exact structure of the backend. They're saying a user has these exact fields, an age is an integer, the name is a string, and here's what each one is, right? And this API takes these inputs, and here's the type of each input, and then it returns a response, right? So both of these, I don't know if it's easy to see them, but I'll just explain to you what they are, because I can barely read the one down there, so I'm assuming none of you can read that. But they're both explorers for the GitHub API, and they're both doing the same thing. The difference is, if there's a filter, there's an affiliation filter on the top. If you're accessing this filter, it gives you, because this was explicitly defined what the types were, when you access that filter, it gives you all the options in autocomplete, right? And if you type it wrong, it tells you typed it wrong. In the bottom, you can type whatever you want, and until you run the API, you won't know what you did wrong, right? And then this is if it's a very well-designed API, right? And let's hope that the documentation was in sync, right? Maybe they forgot to update the documentation. GitHub, I'm sure they did, but like smaller company, it's easy to forget, right? So what we have here is static typing, dynamic typing. But even beyond this, if you make a change to the back end, you will know all the places in your code that's accessing that data, and you'll see this in the demo. And you'll know what you're potentially breaking, right? This is not possible with REST unless maybe you can try and grep and hack it together, but it's not that easily doable with dynamically typed languages. There's still, this is mostly there, right? Front end, if you use statically typed languages on the front end and use a component-based framework, you've mostly solved the problem. And the static typing helps manage the dependencies. And on the back end with GraphQL, all your API requests, if anything changes on the back end, you'll know that they impacted those queries, those API requests, and then you can go and fix them or make a more careful change, right? But that's in the back end land, and this is in the front end land. There is still a missing piece because the best way to manage these dependencies is to have static typing across the full stack, right? That means with code, what that means is like, imagine you could make a change on the back end to a field, and if the static typing was across the full stack, you would know exactly, you would know that it broke this query, and you know that that affected these components, right? Imagine you could see all those links, right? With code generation, you can do this, and I'll show you in a minute how it might be possible for you and how we're able to do it. And what that means is, if there's a user entity on the back end with these properties, there will be a corresponding user entity on the front end. And if you update the user entity on the back end, you regenerate the user entity on the front end, and then you'll know when things break. Okay. So I'm going to get into a demo. Wish me luck, guys. This is live coding. So I'm going to build, let's assume on our mobile app. We're doing it on mobile just because it was easy to put together, but this applies to any stack, including web. Let's say you're chatting with somebody within our company. You're chatting with somebody. It's much easier because they're in different time zones to know their local time. So we want to be able to show their local time. Let's keep it simple so you can kind of get the concepts behind it. Okay. Put that over there. All right. So I already copied and pasted a few things, so you don't have to watch me like writing boilerplate. But let me click on one of these conversations, and then on someone's profile. Right now, it's just hello world, right? So there's nothing there. If we go over here, and you look at our folders, this is a fairly new app, so you're not going to see too many folders. There's a folder called profile I created for us, and profile screen. So everything related to profile will stick inside of the profile folder. So, okay. So this is just, in React it would be similar. It's just instead of like these classes, you have tags, right? Same idea. Yes, sure. Is that hard to see? Okay, I've never changed the color on my editor before, if anyone knows how to do it. Or I might have done it a while ago, but gotta love live coding, right? Settings, I would assume it's settings. Color theme, oh, that's, okay, good. So let's, light, okay, there we go. Thank you, everyone. So if anything else, if you guys can keep helping me out throughout this demonstration, that would be amazing. Okay, so this is a smart component we created, which means like it takes care of a lot of the boilerplate, but it'll preserve the idea of what I was talking about, right? So I'm going to just briefly talk about the three concepts, right? One is you're breaking your app up into small apps, right? So here we have our profile app. You can think of it like an application. Someone wants to work on profile, they go to the profile folder. Then we're composing it together. And you saw how before we can just, this is a component, right? So it can just be dropped into anywhere in any other application, right? And that's the only dependency is how people interact with that component. And then finally, there's static typing and using static typing on the full stack, and you'll see the benefits of how the dependencies get managed there. All right, so let's say I want to write. So first, we'll write our API call. Okay. So let me just get the variables first. So this is in GraphQL. These would be the variables you pass into the API request. In this case, all we need is not the widget, the user ID. So, okay. And my gosh, okay. How many quotes is that? There's 3 quotes. Okay, so now let's write a query. So let's call it getUser, give it an ID. Let's type user ID. We're actually working with we're going to be working with the Apollo team to improve some of the code completion you get in GraphQL. But notice how I type user and it's saying fetch a user by ID, right? The documentation's already in there. If I scroll over here to the back end, thankfully it changed the themes everywhere. You'll see that this is the exact same documentation the backend developer is writing. So as they're writing their API, the documentation is right in there. It's part of the code. So if they change the documentation, it'll get synced over here. So let's say, okay, now let's see what fields we have available. Okay, ID, we want their ID. His name, okay, see? Name, again, see? Full name of the user, it's taken all the way from there. Okay. And, oh, this is, let's see what we got here. This is not a subtype. Let me just reload this, and that's the easiest option. Okay. Let's see. Oh, this may, let me rebuild these. So what you'll see is that with static typing, it's not just about managing dependencies, it's also about getting documentation right in there. And because everything's linked together, your tooling can actually help you out a lot. If this doesn't work, I might need to... Andre, any ideas? Okay, let's see. Okay, I'm gonna show you some other things while we're troubleshooting this live coding session. Okay. I think this is the classic mistake. I think you're not connected to the right instance. Let's try this one more time. All right, so we have a typed query that comes back from the response, and you can say var user equals data dot user, right? So because of code generation, this query this type query, we get back a typed user, and we can use that typed user within our application. So I'm just going to start writing this, and then we'll see what happens. So I'm gonna put in the user's name to start with. Okay, well that's not going to work out then. All right, let me just put in the final result and see if that works. If that doesn't work, then I'll just walk you through how this will go, how this might have gone if we didn't get a list dynamic issue. Okay, let's just fast forward past that. Just erase this from your memory. Imagine everything went well. Like imagine an alternate universe where I typed exactly the right thing, and then like we ended up here. Okay. So let me walk you through what we have over here. So if you see here, user.timezone, like user.timezone here, is available based on the backend, right? Any change that we make stays in sync with the backend just by running a command. Okay. So if I were to write user.name_e, name e is not defined. It will tell me that, right? That's on the front end, right? If I were to type that, that's not defined, right? These don't exist, and it will tell you that, and your tools can help you help you with this, right? So again, imagine like somebody comes to the profile screen and all they have to understand is this folder, right? And then they come to the main widget and then they just see the APIs up here and they see this down here and the developer experience of just getting code completion and it correcting you as you're typing, right? So now let's walk through the scenario and let's hope this part of it will work, where you have another feature request. Someone wants you to add skills. So you want to not only see their local time, you want to see what skills they have available. Okay, so you say, hey, backend developer, can you add skills to the backend? And I'm just going to comment this out because I'm not going to implement skills as you're watching. So now we add this to the backend. And if we recompile this, imagine you ask him to implement this. You go to sleep. You wake up the next day. Skills are implemented. So right here, if I type skills, can't query the field skills, right? But let's reload the schema. Now, skills are available, right? So you saw how all the way from the back end, it flowed all the way to the query, right? And if we regenerate our types, now we'll see user dot, probably need to wait a little bit for it to pick up. You'll see here actually the generated. This is generated from the back end. So everything that's on the back end has corresponding types on the front end. And you'll see now, you see there is a list of skills. Apparently VS Code didn't pick it up yet, but there we go. Took a little time to catch up. So I'm gonna add this. I'm gonna add this to right in here. So I'm gonna say tag list And tags, here, it's a list of strings, right? And you can match that up with, well, what's user.skills? It's also a list of strings, right? So the backend developer in their documentation, and here you see it shows up. The backend developer in their document, in their API actually specified that this was a list of string. They wrote the documentation next to it. That came through to the query. And finally, in your types, you can run it and you can see the result in here. All right, finally, let's look at deprecations and errors, right? Well, let's say we deprecate time zone, right? For one reason or another, it's not accurate. Let's deprecate it. So imagine the backend developer. I'm not going to write a real message, but you might get the idea of how this might work. And you got to type recompile properly. So if you come over here, let's reload our schema, let's do the drill. Reload our types. But you'll see now here in the problems panel, under VS Code, user time zone is deprecated. And that's coming from the back end, right? And this time zone property in this file is deprecated, right? So imagine, this is a very small example. Imagine it's a larger code base, right? Imagine time zone is used in like 5 different parts of your application, right? You could immediately know that these applications are using it just by looking at your problems panel, right? And you can keep the front end and back end in sync, and you can keep the front ends in sync, right? You're already kind of doing this work, especially if you use, like, if you're documenting your API, you're documenting all the inputs and outputs, right? If you're using React prop types, you're documenting the types, right? So all this work is being done. The only difference is the tooling is not able to help you because it's not part of the language, right? So if you use these things that are part of the language, you can get a lot of these benefits, right? If I were to actually remove it, like if I just got rid of this, it'd be something similar. If we were to reload this, oops. Now this wouldn't even compile, right? Same thing. You could imagine how you might. We don't do this currently, but you could imagine how this might be set up in a deployment pipeline where, if a backend developer has a pull request and that has a breaking change, you could prevent that from being merged. Same with the front end. You could prevent things that, like when dependencies got out of sync, from actually getting merged. Okay, let's see. So just to summarize, independent of your stack, if you have a big application and you put it and you can compose it into small applications and use a component-based pattern to put them back together, managing the complexity of a large app will be a lot easier. And if you use static languages, static technologies like on the front end and the back end, managing the dependencies between those will be easier as well. And you can go back to those days where it was easy to those like glory days where you could quickly iterate and build features. And while we're using Dart and Flutter for this pattern, and like we're using React on some areas, you could use TypeScript or any static language on the front end. Apollo CodeGen will let you generate types. We didn't have it ourselves, so we had to write one ourselves in pure Dart. But if you follow those principles, you can come up with whatever suits your situation. Like it might not be practical for you to move to static types, but even just the concept of breaking your apps into smaller apps might take you a long way. I'd like to thank Dennis, who drew all the cartoons, our animator and illustrator, and Jake from the Apollo team for helping us get some pull requests merged in for Dart support and some bug fixes. Does anyone have any questions? Or do we even have time for questions?
Actually, we have, if you have some questions, guys. So there's some questions. Then I have one. So actually my question, I think, where you're splitting your applications to some small pieces, I believe that you have some components which can be reused. For example, if you have some design systems, of course, you have some buttons, fields, how that works in your small applications.
You might have a folder called common. And so like dependencies aren't something you can eliminate. It's just something to look at and fight against and minimize. So we do have common infrastructure code that we share, like infrastructure for communicating with the API, like the transport, some shared components like avatars. I would encourage you to err on the side of don't worry as much about duplication at the beginning, because anytime you remove the duplication, you have extra coupling. So if you find yourself like, oh no, wait, we already have an avatar over here and here, it's fine. After a while, you might realize, okay, this is becoming too much to deal with, and then you can pull those into a common place. But at the beginning, like we don't usually worry about duplication.
Okay, got it. Thank you.
One small question is about, at first, thank you for the presentation. GraphQL is not used pretty frequently. We use REST in all the cases, I believe, for now, but I hope GraphQL will come to our life faster. It's a nice technology. Actually, the question was about shared components. Who is responsible for building a specific core component? How do you decide this? And do you have your own buttons made by your teams, or it's more business components like avatars in the core library?
We don't have like a really laid down system for this at this point. In terms of who works on it, it's almost, you can almost think about it like it's almost like open source in a way. Like whoever needs it will tend to work on it, or they'll talk to whoever built it and ask them, hey, I need to use this for my own. I need to use this for my own purposes. Like, do you mind if I make this pull request and you can review it, or would you mind making the change for me? So it's very organic. Like it comes out of just someone needing something and talking to whoever they need to talk to. With Git blame, you can kind of know. I mean, if it's a small team, like our team isn't massive, like that number of active developers. If it's a small team, you'll kind of know who's building what. If it's a larger team, you can use Git blame, and you can use like in VS Code, you can use find all references to find everywhere something's being used. Did that answer your question, or you have?
I hope so. Hi.
Hi.
So you are using Flutter for your mobile application, is
Yeah.
that right?
Mm-hmm.
So the question is, did you consider using React Native instead of Flutter? Why did you choose Flutter, and what pros and cons Flutter has if you compare it with React Native, for example?
Yeah, sure. We actually had an initial prototype built in React Native, and our original goal with Flutter was the cross-platform thing was the most interesting to us. We didn't want to have to maintain two separate code bases. But what we found was, in our specific case, we have our mobile experience is chat, and people are not very forgiving if chat is slow. And React Native, you can optimize it, but Flutter is it's far more optimized on mobile. So that's why we chose it originally. This is an experiment right now, and we are looking into moving our entire front-end system to Flutter, because some of the advantages is in the talk, like because it's statically typed. I mean, we could use TypeScript, but the static typing is one. Performance is another. We plan to build a desktop application, right? And then the performance is going to be better. It's just simply going to be better on Flutter. So we're going to wait and see, like on the other platforms. But right now we have a Flutter mobile app, a React web app, and an Ember internal app, which I'm sorry for my team that I built it in Ember, but that's what I knew at the time. So we have this, it's kind of like fragmented. And so we're not able to share logic very well. So like if we build this chat experience and we want internally managers to be able to use this chat within the admin system, we can't. We have to build it again. So Cross-platform was a big one, and then performance was another one. It's currently written in React, but the plan is to move it to Flutter, but we're waiting until it comes into like closer out. Once it's in beta and once it's like further along, we're going to reevaluate it.